What a great day it's been at OpenSearch Con. Just hope everyone's been having a good time. Today we'll be finishing up with a talk about performance, specifically how in the world of performance we have tools that can help us emulate production environments, and we can use that to optimize our OpenSearch deployments and see if they're meeting our business requirements. So in the word performance, why do we imitate? Imitation is synonymous with simulation. So I've actually been getting into F1 lately. It's probably because I've been watching that Brad Pitt movie, and also I come from Austin, and that's one of the circuit locations. And I found out that F1 is pretty interesting because it's the highest form of international racing in the world, and it's also considered a team sport. The teams are usually consisting of drivers, strategists, mechanics, and engineers, and they spend a lot of resources on putting these drivers into simulations. These simulations aim to replicate characteristics often found on race day. These characteristics include the weather conditions, different characteristics of the track and the circuit, like the different turns, as well as the current car setup and any modifications they plan to make. So this really creates an opportunity for the driver to do iterative testing and find ways to optimize their performance in driving. They can also give feedback to the team members on how to improve their current cars and modify it in any way. This isn't just limited to F1. This is happening in several different fields like aviation and space exploration. And in the OpenSearch community, we're trying to do something similar. We're trying to provide tools to our users to help them understand if they are meeting their business requirements, and in turn, they can give feedback to us on how we can improve OpenSearch and its performance. My name's Ian, and I'm a software engineer at AWS. I've been here for the last 5 years working in the OpenSearch space, and I've been a maintainer of the OpenSearch Benchmark project. This is my colleague, Govind Kamat. He's the senior database engineer at AWS as well. Also been in the OpenSearch space for the same time. He's also a maintainer of the OpenSearch Benchmark project. So for those of you who don't know what OpenSearch Benchmark is, it's the flagship performance testing suite that comes with benchmarking features as well as scale testing features. And it debuted in May 2023 with 1.0, and since then it's had 15 minor versions and 270,000 downloads on PyPy. Our community has increased by 5-fold, the number of maintainers has tripled, and the workloads that it comes with has increased by 50%. In fact, we actually just released OpenSearch Benchmark 2.0, and we're pretty proud about this one because it streamlines the entire benchmarking process in a way that's more intuitive and easier to understand. And it also drops a bunch of game-changing features, some of which we'll talk about today. I want to go back to the workloads that come with OpenSearch Benchmark. OpenSearch Benchmark provides these workloads for users to simulate different OpenSearch use cases that are quite common. The most popular ones are seen here on the screen. So for example, we have HTTP logs, which simulates log analytical workloads. We also have Big 5, which is the big 5 areas of search. We have NYC taxis for taxi cab data. We also have geolocation workloads. And we also have AI and ML use cases as well, like vector search and semantic search. And these are dubbed pretty much the official OpenSearch Benchmark workloads, but they also have another name. They're considered generalized workloads because they have publicly available data, and they carry canned queries. So these generalized workloads containing generalized data and canned queries, we found out that they're really great for establishing baseline numbers for comparison purposes. They're easy for reproducing results across different environments, and they're great for just tracking OpenSearch development. But when it comes to answering questions related to your business and if your OpenSearch cluster is meeting your business needs, they're not so great because they lack complexity and the unique characteristics often found in production workloads. They also lack the workload-specific edge cases found in production workloads that cause performance regressions. And they're also quite lacking in scale because a lot of our performance workloads are ranging from 30 to 75 gigabytes when many production environments are much larger than that. I'm sure you know. So to sum it up, generalized workloads have proven their purpose, but they also lack representation. And this creates a huge gap in the benchmarking experience. Luckily today, we're going to be talking about 3 features in OpenSearch Benchmark to help mitigate and address this gap. The first exists since 1.0, and the next 2 are available starting in 2.0. But before we dive into that, I want you to imagine yourself as a financial institution that's ingesting trading data on a daily basis into an OpenSearch cluster. So you heard about OpenSearch Benchmark and all its glory and how it can make you understand how to optimize your OpenSearch cluster. So you head on over to the workloads repository and you look through all the different workloads that are available. But you don't see anything that resembles your production environment. So you come to us in office hours and you ask, hey, where are all the financial workloads? So we'll tell you, hey, you can use this different feature that exists since 1.0 called Create Workload, and you can create your own custom workload for your use case. How Create Workload works, basically you can point it to a production environment, and it will draw out all the production documents and allows you to attach any production queries that you might have. And OpenSearch Benchmark will wrap that into a workload that you can run in any test environment. Our users have told us that this allows them to find realistic performance predictions, as well as identify bottlenecks before they happen. They can also play around with different settings to see how they can optimize their OpenSearch performance for their use case. In the end, they develop a better understanding of their production workload as well. We're not going to talk too much about Create Workload because we talked about it earlier this year in Amsterdam. We have a whole talk on this. It shows you how to use Create Workload and actually shows you how to use it with a specific production workload as well. So we highly recommend you check that out. So you're that financial institution that has that custom workload and you can use it to benchmark and you found out you got realistic performance predictions. Great. What's next? You might have additional concerns. For example, what about privacy and scalability? When building test workloads over the last few years, we've realized there are 3 pain points when it comes to building them: representation, privacy, and scalability. Create Workload only addresses one facet of this because it's actually drawing production documents out of your production environment. But when it comes to privacy, it's not so great. Some of these workloads, like financial institution workloads, contain PII. Can't just easily extract that out and store that somewhere where someone can just grab it. Some users want to test the scalability of their workload. For example, they might have 1 terabyte of data in their production environment, but they want to see what happens if I have 10 terabytes of data in that same cluster. What will happen? And Create Workload doesn't address that aspect either. So we've actually developed a new feature in OpenSearch Benchmark 2.0 called synthetic data generation. And we believe it addresses all 3 facets because you can now generate data that looks like your production environment's data. And it doesn't violate any privacy concerns. And you can generate as much as you want. On a high level, this is how we designed the synthetic data generator in OpenSearch Benchmark. Users can provide a Python module or an index mapping and an optional config. We'll go more into these later. But OpenSearch Benchmark recognizes these inputs and it builds a blueprint based on what they are. It passes this to the synthetic data generator, which spawns a bunch of different Dask workers to generate these documents in parallel. So under the hood, the synthetic data generator is powered by Dask for parallel computation, Pydantic for schema validation, and Mimesis for speedy data generation. So this is the overall process of generating synthetic data in OpenSearch Benchmark. It actually really starts with first understanding your data before even going into OpenSearch Benchmark. And then you choose an approach within OpenSearch Benchmark and generate data from that approach. And lastly, you can just wrap that data into a workload that you can run in any test environment. When it comes to understanding your data, it often feels like this: staring at a wall, just a bunch of documents that all look the same. And it's hard to understand any patterns from this. But we actually have a few questions that you can ask yourself to guide you in understanding your data. These questions fall under 2 broad categories: data and runtime. For the first category, you want to understand questions such as, what does your data look like? How is the index mappings, the field types? Are there any nested objects, etc.? You then want to see, okay, for each of these fields, what's the data distribution like? For example, if I have a field called color, how often does blue appear compared to red, green, and yellow? You also want to look at field relationships to see how does field like A and B relate to C. And lastly, you want to see, am I paying attention to all the other outliers and anomalies? You also want to look outside of the data itself and see how things are interacting with it. For example, with queries, you want to understand how is this data being accessed and used. You also want to understand how the OpenSearch cluster performs when this kind of data is being ingested and loaded. We understand that this is a lot to understand and it requires a lot of bandwidth and time. And that's not what all users have. So We're developing a feature called Workload Insights that automates this entire process, answers all those questions, and puts it into a single format that you can actually put into a visualizer or feed into synthetic data generation. It's intended to serve as a way to be a new standard in OpenSearch ecosystem and allowing users like solution architects, developers, and more to encapsulate characteristics from their production environments in a sanitized way. And when you feed it into the synthetic data generator, we're hoping that the workloads that are generated are more aligned and realistic to their production counterparts. So to keep things simple today, let's just look at the document structure and understand that. So as you can see on the right side, I have my index mappings that contains fields with keyword values, dates, doubles, and longs. I also have an example document on the left. As you can see, we're tracking the actual asset, the asset type, the exchange it came from, the different prices at different points of the day, the volume, the market cap, and the bid and the ask. So now that we understand this data, let's actually decide on an approach we can use with the synthetic data generator. So we have two options, as mentioned earlier. We have an index mapping we can provide, or we can provide our own custom logic. Let's first look at the index mapping. So when you feed an index mapping into the synthetic data generator, it essentially activates the first technique, which is just random data generation by default. And this is the most naive form of synthetic data generation, believe it or not, and it serves a good purpose. But many of our users will probably want to use rule-based generation technique. So what this is essentially you provide rules, and the synthetic data generator will generate data based on those rules. So let's actually just focus on the price fields here. As you can see, they're all doubles. And let's say we just wanted to override one of those fields to have a value between two different values. So let's focus on price.open. We can actually pass in a config and define a rule, price.open here, and we can say I want to generate a double for this field, and I want it to be between 80 and 90. And you can do that for as many fields as you want, and SDG will adhere to these rules. But let's say you just want to override all the doubles in the document. Well, you can do that too by specifying just the type of mapping field type, which is a double, and specifying the min and max value. So this is a really good balance between automation and customization without really writing any code. We plan to add a bunch of other techniques for synthetic data generation that's built into OSB, such as anonymization and masking, data transformation, generative models, and even Markov chains. The other approach is providing your own custom logic and defining that in a Python module. So sometimes it's pretty hard to depict relationships between different fields or create certain variations just through a config. So we've given users the option to define their own logic in a Python module. So for example, focusing on those subset of fields, open, high, low, and close again, we can actually generate realistic price variations, like 30% or so. And the synthetic data generation will just follow lead and follow these instructions. Even for bid and ask, those fields, we can actually create a very specific percentage of spread between the bid and the ask price. So now that we understand how to generate data with OSB, let's actually do it in a live demo. Okay, so just pull up this instance. Okay, so as you can see, I have my index mappings here for the financial institution. It's the same one I showed on earlier slides. Let me just full screen this so everyone see. So we have those different data types. We have some objects. We also have our config here where we define some rules. As you can see, I've overridden pretty much most of those fields, and I've also had some generator overrides as well, which override pretty much all those types. But just to know that field overrides are always going to take a higher precedence than generator overrides. So you might have overridden all the double fields to be between 0 and 2000, but let's say we only have price.open in the field overrides. It's going to adhere to this one and follow this one first for that field. So let's actually look into how to generate that data. Okay, so I have a command here, and I'm basically passing in the index mapping And I've defined the data corpora name that I want, as well as the total size in gigabytes. I've also provided the output path of where I want this data to be dumped. And before I generate this data, what if I want to just check how it looks like? I can provide this flag. So as you can see, it shows you what an example document might look like. And it's not that impressive. It just has random values, but it has the structure. And this is really good for when you want to stress test your cluster with just documents, and you don't really care about what they actually have. So we can actually provide a custom config as well. So with those rules defined, I can check what that might look like. As you can see now, I have an asset called Amazon, and this is the asset type. This is the timestamp format, and these are the different prices. I've also overridden them to be between values of 80 and 110. And I've also created, I think, a market cap of a certain value. I've defined a rule in the config or so. So that's just basically how index mappings works. And they all follow the same workflow, essentially. So I'm actually going to show you how to actually generate the data with a custom config. So I have my custom config here. And this has the most granular rules, as you can see. It's the same rules that we saw in the earlier slides with the spread between the bid and the ask, as well as the 30% variation between prices. And we have a bunch of other rules we've defined in these separate functions. We also have a main function, essentially, and when you provide your own custom logic, the OSB expects that one of the functions is called generate synthetic document, and it pretty much should tie in all the other logic. So let's actually use this to generate documents, and let's show you what happens. So I just have the command ready here. So I'm not going to provide the test document flag. I'm just going to generate it. And as you can see, I'm just overwriting some of the files I already have. OK, so it's going to start generating documents now. And as you can see, there's a max file size here. This is by default 40 gigabytes. And why users might want this, because they might be storing this in cloud storage. And there's certain sizes that are limited. For CloudFront, for example, which is 40 gigabytes. So aside from this progress bar, we can also monitor the synthetic data generation from the DAS dashboard, which is pretty interesting. So if I have this here, I have this DAS dashboard. I can actually monitor in real time how the workers, which I have 8 workers for 8 cores, are generating batches of 10,000 documents according to that custom logic that I provided. And you can monitor the CPU, you can monitor the bytes stored per worker. You can even get more details. For example, I can look at the memory usage, and you can see how all these workers were taking a break, and now they're jumping up to create those 10,000 document batches. And an additional functionality that's pretty cool is this profile capability. And this is really useful, especially for custom logic, because you might be defining certain rules through Python code, but it shows you where most of the time is being spent in that code. And you can optimize it, you can make it faster, and you can generate maybe 1 terabyte a lot faster than before. So that's pretty much how to generate synthetic data. And we can go back to the presentation. We've shown you what it's like to just provide the index mappings, which just populates all the document fields. And then we've also shown you the best of both worlds, which is automation and customization, simply providing the index mappings and some rules in a config. And lastly, we've shown you what it's like to have the most granular control over how the data is being generated through custom logic. We've also walked you through the DAS dashboard and how it's super useful when generating synthetic data, and also how to profile your custom logic. So now you have other ways to generate workloads aside from just stripping them from your production documents or production environments. You actually can generate workloads containing synthetic documents and modified queries. But there are still some challenges. For example, how realistic is this workload that I'm generating? Are there any biases that I introduced? And production workloads are always a moving target, so you always have to update your synthetic workloads to make sure that they're up to date. And lastly, did I ensure that the workload captured my domain specifics? So now I'm going to pass it on to Govind, who's going to talk about the last feature in OSB.
Okay, thank you, Ian. So Ian has given an excellent exposition on synthetic document generation, create workload, and the importance of modeling your production deployment. So how many of you are convinced that creating a custom workload is the way to go? Yeah, looks like he has done a good job of softening up this hard-nosed audience, but I guess there are still a few holdouts. In addition to the F1 car that Ian talked about before, there is also another high-performance machine, which is the F-35 fighter jet. So the US Air Force, before they let even their best pilots on that plane, they have them go through the Lockheed Martin simulator and train them over there. So just like that, if you're trying to model your production deployment, creating a version of the deployment that actually works well on your system is really important. So once you have your shiny new custom workload, is your job done? Well, the other part of it is actually running the workload. And if you're going to use OSB 1.0, it may not have all the features that you're looking at to run that workload. And why is that? When you go ahead and carry out a test run, there are two phases. There is an ingestion portion, followed by the portion where you're actually querying, running the queries. And let's take the queries first. Traditionally, when OpenSearch Benchmark carries out the query phase, it typically goes ahead and runs one query at a time and provides the latency information. I mean, that's not really how you go about carrying out your real production workload. And the reason OSB does that is because it wants to provide precise and repeatable latency measurements. I mean, this kind of information is important for performance engineers and developers to understand the areas where OpenSearch can be improved. In reality, when you are running a workload, you have a mix of queries that run concurrently. So you may want to go ahead and carry out a run where you have a particular set of queries that you run at the same time, or you might want to run some amount of ingestion along with your queries. That is a harder job to do. We will cover some of this. Rishabh Singh is going to have a presentation on describing how you can carry out these concurrent workloads where you have these mix of your choice of queries and ingestion as well separately. If you want to look at the ingestion portion of running your workload, that is also an issue with the version of OSB 1.0. The workloads that come with OSB typically have had data corpora in the range of 30 to 50 gigabytes. I mean, that's not really how people are running workloads these days, where you have clusters in the tens of data nodes to maybe even 100 data nodes. So there is a lot more data that you need to have ingesting into your cluster. So if you take an example, maybe with the ingestion mechanism that's being used in OSB 1 is somewhat like a fast running stream over here. But if you are looking at trying to run it with terabytes of data per day, that is like a river, a massive river like the Amazon or the Nile. And OSB did not have the capability to do that in the past, but with 2.0, we have a new feature, streaming ingestion. So I give you the motivation for why we need this. In addition to the fact that you have clusters that are much larger in size, users are also keenly interested in being able to model cases where they have continual streams of data that arrive continually and infinite streams that really don't end. So you want to carry out this kind of ingestion in a continual phase. Large data corpora are also not that easy to manage. When you have a terabyte of data, how are you going to package it up? Are you going to compress it, download it, partition it on the fly? That can take a long time to consummate. So with synthetic, with streaming ingestion, This is a schematic of how this operates. Essentially, the whole idea is that you can have your data arrive from a variety of data sources. In this version of streaming ingestion, we are supporting synthetic data generation, which is the first box on the left side. But you could choose to have your data arrive from data prepper or maybe a Kinesis stream or Kafka, or even you might have some data files that you have generated in the past and you have stored somewhere. The common storage for all of this is some form of cloud storage. As long as you can take these data sources and put them into cloud storage as objects. Currently, we support S3, but this is not restricted to S3 by any means. In the future, we hope to have support for other cloud storage models like Azure and Google Cloud and so on and so forth. But currently, we do support S3. And as long as you have these objects, what streaming ingestion will do is that it will download these objects on the fly and partition them into chunks, as opposed to with OSB 1.0 where you do this partitioning after you do the entire download. So this is a continual process, and as these chunks get downloaded onto the load generation host, they get farmed off to these various clients. So let's say you have a 4-node cluster and you've got 4 clients. The blocks in red are the ones that are being processed currently. As clients finish with their chunks, the older chunks get deleted. So when a client processes a chunk, I think I lost something.
Oh, here.
Yeah, can you hear me? Maybe not. Okay, I can speak loud. So when a client processes a chunk, it goes ahead and partitions it into smaller sized bulks, and it stitches them together across multiple chunks. So this goes on, and as new chunks arrive, the clients will move on to the newer chunks and the older ones go on. So when the entire, in this particular case, you can see file 006 gets processed currently. After it is done with, the streaming ingestion module will move on to the next one and proceed on until all of the objects are consumed. So let's go to the next slide. So yeah, this is sort of what, this summarizes the operation. So essentially we are downloading the documents in a multi-part fashion, so with a large number of concurrent threads for performance. And as the process proceeds, there is an orchestration between the downloader and the clients. So if the downloader is fast enough, it is halted so that the clients can catch up, and vice versa. If the clients are faster, the downloader will be halted. So ingestion depends upon the cluster size and capacity. So if you have a small cluster, you're not going to be able to get the high ingestion rates, obviously. So you need to have a cluster that's sized to the load that you expect. You might want to go with a serverless implementation as well. So this is completely independent of the system under test. And we have seen data rates up to and beyond 10 terabytes per day. So depending on the density of the documents, it can range from, let's say, 8 terabytes per day to maybe 15 terabytes a day. And this is with a single data node. So in the future, we hope to have support for a split of nodes where you can go to multiples of tens of terabytes per day. So how do you go about using streaming ingestion? So on the left side, you can see the workload template for a standard OSB workload. I'm not going to go into the entire portion of the workload. This is just the data corpora section. So if you look at that, it's fairly straightforward. You just indicate the location of the corpora, which is the base URL, and you also indicate the name of the file where the documents are stored. In this particular case, OSCon Finance, 10 gigabyte. At the same time, you need to also specify the number of documents and the size of the file so that OSB knows how much to download. With streaming ingestion, there is no real concept of number of documents or a size of the file because you might have infinite stream of data. So those fields are skipped. In addition to that, you have a tag which says streaming ingestion, and then there is the base URL. So the base URL, rather than basic URI, it points to an S3 bucket in this particular case. So with these three arrows on the right side, you have all you need to specify your data corpus. So we are using a wildcard over here, OSCon finance with a wildcard. So it's going to consume all the objects that begin with that prefix in sequence until all of them get finished. So we're just going to do a quick demo on showing how streaming ingestion does work. I'll have Ian take over here. So essentially, he has already generated a data corpus based on from a synthetic document generation module, and we are going to just have that ingested by a streaming ingestion as opposed to the old style OSB 1 ingestion. So we go through the regular steps. We delete the index in the beginning, create a new index just to get things started from scratch. Once that is done, we check the cluster health and then proceed into ingestion. So instead of saying 100% done or 5% done, I mean, we don't really know how much is done, because on S3 or the cloud storage, you might have new objects continually appearing, and so really there is no end. So what OSB 2.0 does is present the number of amount of data that has been ingested so far. So you can see that it's going up pretty rapidly here. We are going to about 3 gigabytes already. And I think this is going to proceed until the job terminates. We don't really have time for that, but I think we can take a look at the data that as it gets downloaded. And I think we should see chunk files that arrive and get processed. Yeah, so here you can see that there is a set of chunk files, and then these will change, the numbering will change as they get consumed. Yeah. So how many of you are now convinced that the custom workloads are the best things in sliced bread? Well, I think they're great. I think they do a great job of modeling a production workload. But then they are not the end all and be all. There is still a place for generalized workloads. I mean, your custom workloads are going to keep changing. Your deployment is not going to be the same from time to time. It depends, all of this depends on the queries and the accuracy of your model as well. So while custom workloads can give you a good sense of your production deployment, in other cases you might still be interested in specific performance for specific features of OpenSearch. And in that case, the generalized workloads, the queries with the generalized workloads have been crafted very carefully and are more repeatable and accurate from that perspective. And your custom workload, if it is of interest to a lot of people, might be converted and encapsulated as a generalized workload. It might be packaged as part of OSB and presented to a large audience. So there is certainly a place for both of them, and depending on the problem that you are trying to solve, you should decide to choose one or the other. So applications for synthetic document generation and streaming ingestion are pretty vast. I mean, here are just a few examples. Ian chose finance as one of them, but it's anything under the sun: finance, healthcare, e-commerce, manufacturing, and so on and so forth. So what's new in OpenSearch Benchmark? On each of these projects, we've got a lot of new features coming down the pike with regard to synthetic document generation. There's going to be support for time series datasets, anonymization. There are going to be new techniques for anonymizing better and masking these fields. Workload Insights is a massive project. I mean, it basically canonicalizes workloads so that people can share them across various different disciplines. On streaming ingestion, we're going to, in OSB 2.1, we'll have support for infinite ingestion. We will have better meshing with synthetic document generation, which is now a two-step process. We're going to be able to, in the future, focus on having a fleet of nodes and orchestrating them better so that you can go way beyond 10 terabytes per day. And there are many others. Please keep posted on that. So OpenSearch documentation is on the left side. The link to download OpenSearch Benchmark is on the right side. We have a bi-weekly community meetup where if you have questions, we have office hours. So that's a great way to meet the rest of the community and bring your questions and suggestions and ideas for enhancing OpenSearch Benchmark further. And that is the link to OpenSearch Benchmark, the GitHub repository.
Cool. Thanks.
Yeah.
I think we have time for some questions, like 4 minutes.